As the Earth rotates daily, the sun appears to rise in the east, move across the sky, and set in the west. You may not have thought about it, but this is an important thing for gardeners to study. When selecting a site for your garden, it's important to know the sunlight needs of your plants. Sun-loving plants need 6 or more hours of direct sunlight. If a garden does not get enough direct sunlight, the plants may be weak, slow to grow, and may produce very little fruit. Light intensity changes throughout the day based on the location of the sun, and you can monitor it with the right tools. How does the angle of the sun's light affect the level of light intensity that can be absorbed by plants in a greenhouse? This is how a greenhouse works: light. Many factors go into selecting the proper site for a greenhouse, such as access to utilities like power and water. Another important factor is how much sunlight makes it into the greenhouse. In this activity, you will investigate how light intensity or brightness depends on the angle of which the sun's light strikes the surface of the ground and how this changes throughout the day. Okay, for the setup, first off, this is best to do with a partner because you're going to have to use both hands when you're manipulating the model of the sun. So again, having 2 folks is best. I'm going to show you how I'm going to do it on my own here. So you are going to need a shoebox or a cardboard box, some white paper, a protractor. You're also going to need a ruler. I like having my handy dandy meter stick close by. I also have, of course, a PASCO light sensor, scissors, pencils, markers to do your markings, and tape. And again, since I'm doing this on my own, I'm using this ring stand so I can get the right measurement. Essentially, you're going to be holding your model of the sun 40 centimeters from the bottom of the box. And you can see how I have the white in the bottom of the box. I've used my protractor to mark my angles that I'm going to have for my sun: 45, 60, 90, 120, and 135. And I think that's all we need. Oh, of course, you need a model of the sun. So you can use a gooseneck lamp. They're the ones that you can move back and forth. I like using this handheld one. And for this, I'm using an incandescent 60-watt light bulb. For the light activity, you could use LED if you wished, but there's an activity that follows this where you would need the incandescent light bulb focused on a greenhouse activity. Okay, so it's time to collect some data. I just want to point out, you might have noticed the lights have changed here in the studio, and we did that because you're going to be using an ambient light sensor. And I'm going to show you why it was important for us to lower some of these lights. You might have to do it in your classroom, you may not. So I'm going to connect my light sensor to SparkView. Make sure luminance is checked off under ambient light sensor, and then you need to disable the spotlight sensor. And then choose the digits display. If you look at the bottom left-hand side, you notice that right now it's saying the luminance is hovering around 241 lux. Lux is the measure of light intensity. And if I were to aim this light sensor towards the light behind me, you see how it increases. So just something to keep in mind in your classroom. But these numbers are good. All right, so I have my model of the sun here in my lamp. Remember, I'm using an incandescent light bulb for this, and it gets warm, hot very quickly, so make sure you do not touch it under any circumstances. And for this, I'm going to mimic how the sun appears to move across the sky during the day, and I'm going to collect data for lux for 45, 60, 90, 120, and 135 degree angles. Okay, so let me get this positioned. It needs to be 40 centimeters from the bottom of the box, and I believe we're good to go. I'm going to start collecting data. 45 degrees is 447.04 lux. 60 degrees is 541.54 lux. Now I'm getting to 90 degrees. Some might have heard of the term high noon. I am 701.46 lux. Moving to 120. I am at 566.98 lux. And then 135. I'm at 419.79 lux. Okay, so that data should be in your data table. I'm going to turn this off for a second. There's no need to save this particular run, so I'm just going to start a new experiment. Go back into sensor data. Again, make sure your spotlight is disabled. And this time I'm going to choose the line graph because I want to show illuminance over time. So I need to get in position, turn on my light, and I'm not going to stop. I'm going to do this in one fluid motion to get a nice line graph display. Again, 40 centimeters. And start. And stop. All right, and you can scale your graph to fit. And this is a point where you might want to save your data file because you're going to refer to it for your data and analysis portion of the activity. So the data and analysis portion of this activity is pretty straightforward. You're going to refer to Table 1 where you took your data by each angle individually, and then you're going to refer to your line graph here to answer the questions that you find in your student activity sheet. Good luck.